Design of electromechanical systems experimental demonstration. DC motors as generators. Direct current motors, referred to as DC motors, are machines that use electrical energy to transform it into mechanical energy through a magnetic field. This field is created and maintained by the direct current. The field repels and attracts magnets located on the rotor. This force causes the rotation of the motor. To keep the continuous rotation, the commutator that is attached to brushes connected to the power source supplies current to the motor wire windings. Brushed DC motors can be used as DC generators through the law of induction. Rotating the shaft of the motor moves the segments of the windings through the sinusoidal varying magnetic flux. Proportional voltage to the shaft speed is generated when the shaft of the motor is driven. This can be seen with the formula below. A list of tools that you will need to recreate this experiment. 3 3-volt DC motors, red wire, black wire, a plastic fan blade, a 100 ohm resistor, a red LED, a breadboard, wood, 3 plastic harnesses, 3 wood screws, a 9-volt battery, a switch, a hairdryer, a plastic axle, solder, a soldering iron, and a multimeter. With these materials, follow this circuit to recreate the model shown here. In the first demonstration, you will see that 9 volts applied to the first motor is enough to turn the shaft of the second motor, supplying power to both the LED and the fan motor. In the second demonstration, I use a hairdryer to simulate wind energy. You will see that the wind created by the hairdryer is enough to generate enough electricity to light the LED very brightly, as well as energize the top motor, which will then turn and generate more electricity on the bottom motor. My design was able to generate electrical energy in 2 ways. When the 9-volt battery was supplying power to the bottom left motor of the above image, the top left motor generated a measured 0.95 volts and was able to illuminate the red LED as well as power the fan motor. My design's second function was to simulate wind energy by using a hairdryer to blow air onto the fan motor. This approach measured a 3.59 volts and not only illuminated the LED, but also supplied enough volts to the top left motor and generated up to 0.67 volts on the bottom left motor. This supports the law of conservation of energy, as well as the law of induction, because when the motor turns the shaft, they convert the mechanical energy into electrical energy that then can be used by electrical components such as the LED or the other motors. I was successful in demonstrating how DC motors can be used as generators for electrical energy by using both another DC motor and simulating wind energy. If I were to redo the experiment, I would use a high-quality multimeter to get more accurate results on measured voltage. This experiment relates to mechanical energy systems because it demonstrates both Faraday's law of induction as well as the law of conservation of energy, which states that energy can neither be created nor destroyed, only converted from one form of energy to another. Thank you for watching, and here are my references.